Hello, hello. So I'm going to go over the chapter 8 practice test, the one that you mailed to me. And so I'm just going to go through how to do some of these problems. And then hopefully, if you got questions, go ahead and email me if I need to explain something. But hopefully after going through it, it should make some sense. If you want, you could go to Moodle and print out another copy of this practice test. And then as I go over it, you can kind of fill things in as we go if you think that would be helpful to get this stuff figured out. So let's start. All right, we've got the formulas on the top. You can look those up if you need to. All right, in this problem here, we needed to find the perimeter and area of this trapezoid. So perimeter, just, excuse me, sorry. For perimeter, we're just measuring the four sides in millimeters. So just for example, so there's millimeters are these little tick marks on your ruler. Sorry about the glare. So you can see this side is 25 millimeters or 2.5 centimeters. So you had to measure all four sides, add them up. You should get 117 or very close. And then to find the area, you need the height, right? Half the sum of the bases times the height. So you had to measure this perpendicular distance between the two parallel lines, and that's 22 millimeters. So there's your formula and your answer. For this one here, you've got a coin, diameter is 2.5. If the coin is made of $20 of gold, how much would a coin of the same thickness but 3 times the diameter? Hint, think, area. This is very similar to the pizza questions we did in class. So you're tripling the diameter, but that doesn't just triple the area, right? If you figured out the area of the bigger coin, so the bigger coin would have a diameter of 7.5. So that's a radius of 3.75. And the first coin has a radius of 1.25. So if you compared those areas, so 1.25 squared times pi, then 3.75 squared times pi. You can see there that the difference isn't 3 times as big. It's actually 9 times as big. Exactly 9. So if we have 9 times the area, the coin is going to be 9 times as valuable. So 9 times 20 is $180. Then this one here, you see I used the burgundy colored pen to add up how many were completely full, and I got 34. And then I used the orange to see how many were partially filled, and I got 37. And you could have, your numbers could be a little different, right? This is an estimate. So here's your formula: full plus partially filled over 2, and then times the area of 1 square. So it's 100 miles from here to here, and there's 20 squares, which means every square is 5 miles on a side. So 5 miles by 5 miles gives you, each square has an area of 25 square miles. So that's why you're multiplying by 25. And your answer should be somewhere right around 1,300 square miles. Moving on. I said that just for Elijah. All right. What is the length of the leg? We're told we have a right triangle. AB is 5. The hypotenuse is 15. So you got to use the Pythagorean theorem to find your missing side. So 5 squared, that's 25, plus this side squared is the hypotenuse 15 squared. And you solve and you get the square root of 200, which is your 14.142. That's the nearest thousandth. And what is the area of this triangle? That's just half base height. So half of 5 times the height, which we found was 14.142. You should get 35.355 or something close. Then for part C, remember we flipped the right triangle, so same triangle, it's just that we put the hypotenuse as the base. And so half of 15 times the altitude has to give you your area. And then you solve for A by multiplying both sides by 2 and then dividing by 15, and you should get 4.714 inches to the nearest thousandth. All right, number 6, the carpet question. This is just like what was on the practice test. This was too, obviously, on Moodle. So hopefully these were very familiar to you. So we got a room that's 17 by 23. So that's in feet, right? And then our cost of carpet is in yard. So that's just to challenge people who don't do math well. So 17 times 23 is 391 square feet, but we need yards. There is 9 square feet in 1 square yard. You could convert these dimensions to yards first too if you wanted. So I'm going to divide by 9, and that gives me 43.49 square yards. So I just have to multiply that by the $14 per square yard. That's the $608.22. Okay, number 7. Many found number 7 challenging. This is kind of like the problem in the chapter review where they had the rectangle and then they had the two discs that were cut out of it. So in this case, we have just one circle with a equilateral triangle. And so you could have found the area of this triangle one of 2 ways. One, you could have used Heron's formula from the front page using the semi-perimeter, or as I did, using the isosceles triangle coincidence theorem, I dropped the perpendicular that cuts the base in half, right? All 3 sides are 8. So then this is 4. And then I solved for the height using the Pythagorean theorem. And so then the area of my triangle is 16 times the square root of 3. So if you did this with Heron's formula and you got a decimal, it would be 27.71. And then I found the area of the circle. That's just pi r squared. So we're told radius of 5 inches. So 25 pi, that's your area of the circle. Now to figure out, we're looking for what percentage of wood is waste. So what I did is I took the area of the circle and I subtracted the area of the triangle. So that's going to give me the waste, right? If I take the area of the circle and I cut out what the area of the triangle was, these 3 sections here are waste. And so this difference is going to be what's the waste. And then to find a percentage of the total wood that's waste, I have to take the area of the waste, divide it by the area of the whole circle, right? Area of the part over the area of the whole. And that's going to give me my 64.7%. So the 50.83, that's the area of the waste. Then divided by 25 pi. That's going to give you the 64.7%. Number 8, the better deal for pizza. Remember here, you need to find the cost per square inch. So for the circular pizza, it has a diameter of 16 inches, which means it has a radius of 8 inches. So to find the area, it's 8 squared pi, 64 pi. So I'm doing $20.99 cost, right? Cost per square inch. Some of you did square inches per cost. So you end up getting how many square inches of pizza do you get for $1, which not the useful way to do. I mean, you can still figure it out, but it's a little bit more clumsy. So here we're taking cost per square inch, and we get, it's about 10 cents per square inch. And this one is a little more, not by much, but a little more. So you say, well, what's 0.2 cents per square inch? Well, it depends how many square inches you have, right? So the rectangular pizza has 288 square inches. And if you're paying an extra 0.2 cents per square inch, it's going to cost you not that much, 60 cents or so extra to buy that pizza. But the point was, how do you compare cost? And remember, this is a life skill. So hopefully you got the idea. I know some of you, just based on our arguments in class, are determined to always overpay for pizza just to spite me. So be it. All right, here's our fair dartboard. And we're told the 10, what makes it fair is that the area of the 10 ring is 5 times the area of the bullseye. And the bullseye is worth 5 times as many points. And if the distance from A to F is 20 inches, so that's the radius of the entire dartboard, what is the area of the 20-point ring? And I say it may help by calling the area of the 10 ring X and the 50 ring a fifth of X. Now, you could have done this differently. You could have called this X if you wanted, and then this would be 5X. But that's kind of up to you. So what I said is that this is X, and then the 20 ring has to have half the area of the 10 ring because it's worth twice as many points. So it's twice as hard to hit because it has half the area. So if this is X, this is half of X. The 30-point ring is 3 times the value, so 1/3 the area. So 1/3 of X. The 40-point ring is 4 times the value, so it has to be 4 times harder to hit, which means it has 1/4 of the area, 1/4 X. And then the 50-point ring is 5 times the value, so it has 1/5 the area, so 1/5 of X. Now, all these 4 rings and this circle all together have to add to the area of the entire circle. So the entire circle is 20 pi. So the 10-point ring, the 20-point ring, 30-point ring, 40-point ring, 50-point circle all have to add to 400 pi. So then I added them together. You get 2.2 283 repeating x is 400 pi. You solve for x by dividing by 2.283 repeating. You get x is 550.352. So that's the area of the 10-point ring. But I want the area of the 20-point ring, so I divide that in half, right? Half x is 20 points. So half times this gives me 275.18. And that's in square inches. Okay? All right. So the answer to this problem was 5, 0. That's where the point is. And the way to figure it out is I said, hint, draw a rectangle around the figure. So we did something like this in the notes. And then we did a problem. You could have used this method on the quiz as well. So we're told the area of this thing is 67.5. And we're trying to find this last side, right, that I drew in crudely, but was not present on the piece of paper. And so what the idea was is that you would find the area of each of these pieces. So like, so this triangle here, 1, 2, 3, 4, base of 4, height of 3. So it has an area of 6. And you could have done this differently. I guess you can make triangle, trapezoid. I drew that line in there, but so you could look at this triangle, 1, 2, 3 by 1, 2, 3, 4. This would also have an area of 6. And then this obviously has an area of 3. And then this triangle here has a height of 1, and then 1, 2, 3, 4, 5, 6, 7. So that's 3.5. And then we got 2 by 1, 2, 3, 4. So this has an area of 4. So far we're at 12 and 3 is 15, 18.5, 22.5 of pieces. And then the area of the whole rectangle is what, 8 high by 12 long, so 96. So we have 90, the whole area, the whole rectangle is 96. We know the inside part 67.5. I guess it's better to use decimal here. So that's 28.5 is what our waist has to add up to. And so we're at 22.5. So if we subtract 22.5 here, we get 6. So we have this, and this add to 22.5. We need, with this section, we need all of these waist areas to add up to 28.5. Because 28.5 and 67.5, the area of the inside figure, gives us our 96, the area of the whole rectangle. So we do 28.5 minus 22.5, we get 6. So we know the area of this has to be 6. And so the height, 1, 2, 3, 4, is fixed. And so the question is, what does the base have to be to give us an area of 6 here? And the base has to be 3. So that's how we know it has to be at 5. Because if it was at any other point, the area of this triangle is not going to be 6. And then my waist isn't going to add up to 28.5. So that was that problem. Extra credit. So you've got a triangle, side lengths 20 and 25. And so first you figure out what could the third side be. So 25 minus 20 is 5. 20 plus 25 is 45. So it can be anywhere between 5 and 45. So you set up two cases. You know by the Pythagorean Theorem that a squared plus b squared has to be bigger than c squared in an acute triangle. So in this case, C is greater than or equal to 25, which means that my hypotenuse of my triangle is going to be 25 or greater. So I get 400 plus 625, because these are the two sides of my triangle, 20 and 25. And then my third side, I'm saying out of this range of, my third side has to be between 5 and 45. I'm taking all the values that are 25 or greater and checking them. And so I solve this, and I get 1025 has to be bigger than c squared. So what values between, so this is really looking at, I should use a t here, sorry, t bigger than 25. I'm kind of confusing my variables here, so I apologize for that. If the third side's t, then let's turn these to t's. There, is that better? I solve for t, and I get 32.02 is greater than t. So what values between where t is between 25 and 45 is, 32 is greater than t. So is t less than 32.02? And that's these values here, 25, 26, etc., all the way to 32. Then I have to check the case of where t is less than 25, right? To check the values between 5 and 25. And so I do 20 squared plus t squared is greater than 625, because now I know my biggest side's 25, right? Because I'm saying t is less than 25. Hopefully by going through this in class several times, this is making some sense to you now. So 20 squared plus t squared is greater than 625. Here's my one side of my triangle, 20, 20. Here's my other side, 25 squared, 625. And then my third side, I'm saying has to be less than 25. That's why it's on this side of the equation. So I solve here, I get t squared is bigger than 225, which means t is greater than 15. Doesn't include 15, t is greater than 15, but has to be less than 25. So that gets me 16 to 24. So my answer is, so I have 16 up to 24, and then I have 25 to 32. So any value between and including 16 all the way up to 32, those are the values for the third side. Again, if you have questions, go ahead and email me. But that's the Chapter 8 practice test.